fuel system is different in a natural gas-powered vehicle than what you may be used to with a diesel or gasoline-powered vehicle. It starts with the fuel tanks. Natural gas fuel tanks are made to carry either CNG fuel or LNG fuel. Both of these natural gas fuels can offer advantages, and choosing CNG or LNG usually depends on fuel availability in your areas of operation, space considerations for your vehicle, and the range requirements for your application. Typically, the truck or bus manufacturer will supply the vehicle fuel storage and delivery systems. Cummins Westport, however, does provide guidelines for the fuel system to ensure optimal engine performance. In general, a natural gas system, whether it uses CNG or LNG fuel, will consist of the fuel tank, fuel lines made of high-quality stainless steel tubing, tank pressure gauges, a manual shutoff valve that is clearly marked to shut off the fuel supply to the engine, and low-pressure fuel filter for service and emergency use, a regulator to control the fuel pressure to the engine, an electronic shutoff valve that is activated when the ignition key is in the on position, fuel filters, and a low-pressure indicator lamp on the instrument panel of the vehicle. A CNG fuel system will utilize CNG that is stored in fuel tanks under pressures of up to 3,600 psi at 70 degrees Fahrenheit or 21 degrees Celsius. Typically, CNG tanks have a capacity of 15 to 25 DGE per tank, and often there will be 3 or 4 tanks packaged as a fuel system on a vehicle. For extra capacity, there are also larger tanks up to 40 DGE that can be mounted on the vehicle frame.
Compressed natural gas is stored on the vehicle at 3,600 psi. We regulate it down to about 115 psi for the Cummins engine inlet. Vehicle configurations vary depending on the chassis layout. From a refuse truck with cylinders mounted on top, which is generally a 60 or 75 diesel gallon equivalent configuration, to a trash truck that might be a roll-off configuration like we're standing next to today, that would have tanks generally mounted on the side of the vehicle, and that can range anywhere from 40 DGE up to 100 DGE depending on the configuration.
Mounting multiple tanks on the vehicle can increase the fuel storage to over 150 DGE for longer range. The CNG storage tanks can be mounted either vertically or horizontally, depending upon the application.
It's not just so much mounting the tanks, it's integrating the tank with a structure to protect the tank that's designed to integrate with the vehicle and maximize the space, the footprint. You want to maximize fuel capacity within a given footprint. So we have a structure, a superstructure that surrounds the tank that generally is designed to protect the tank, integrate with the vehicle, and then we also protect the tank from UV or road damage with aluminum or steel shielding. In addition to that, we have what we call a fuel management module that basically is the user interface. So that's where the operator of the vehicle will fuel the vehicle. They'll have an NGV1 fuel receptacle typically. They'll have a quarter-turn shutoff valve to allow service of the engine. It'll have a coalescing filter, high-pressure coalescing filter.
LNG fuel tanks store natural gas in a liquefied state. LNG is cryogenic and is stored in double-walled, vacuum-insulated stainless steel tanks.
In general, the way the LNG system works is you've got cryogenic, generally minus 200 degree Fahrenheit liquid in a big thermos on the side of the vehicle, and in a general tank size is about 150 gallon gross, which equates to about 80 gallons diesel equivalent, give or take 5 gallons. And so that liquid is extracted from the tank, through the demand of the engine. It's vaporized in a heat exchanger, which is basically a coolant. Engine coolant runs through the heat exchanger around the tubing that holds the cryogenic fluid. It vaporizes, and by the time it gets to the engine doesn't know the difference whether it's stored as LNG or stored as CNG on the vehicle. So the bottom line is the engine is exactly the same. The gas gets to the engine at about 110 to 115 psi.
A typical LNG tank will have a capacity of 60 or 75 DGE, and usually there will be one or two of these tanks mounted on the vehicle. LNG requires about half the storage space as CNG for an equivalent amount of energy. Unique to the LNG system is that it incorporates a vaporizer to warm the LNG to a gaseous state for delivery to the engine. When the engine is not running, the LNG fuel in the tank will slowly return to the gaseous form as the fuel warms, increasing the fuel pressure in the tank.
On an LNG tank on the vehicle, as opposed to CNG, it's stored at 3,600 psi. Your LNG tank is going to be stored anywhere from 100 psi to 230 psi. From the tank, you have high pressure stainless steel tubing, and generally that's going to be stainless steel hard tubing. In some cases, that might be a flexible Teflon braided stainless steel covered hose, or some other form of flexible tubing that's cryogenic rated for at least minus 300 degrees Fahrenheit. From the tank, that tube will go to the heat exchanger, where the liquid is then converted into gas. Downstream from the heat exchanger, we have a lock-off solenoid, which basically is like a fuel pump switch, where it basically shuts fuel flow on and off depending on the key switch. After the lock-off solenoid, we have what we call an overpressure regulator. And what the overpressure regulator does is it keeps the fuel from getting over 150 psi, because the Cummins engine wants to see pressure between 110 psi and 150 psi. Anything more than 150, and you'll have a check engine light for overpressure as opposed to low pressure that we talked about earlier. So after the overpressure regulator, we have a flexible hose that'll take the fuel from there to the low pressure filter, which is generally installed either behind the cab or on the engine. And again, that's just basically a spin-on fleet guard filter that's separating any impurities before it gets to the engine. On every LNG vehicle, it's required by standard and code that you have a methane detection system.
In general, if the vehicle is used on a regular basis, pressure in the LNG tanks will be managed by the system. However, if the vehicle is parked for an extended period of time, the pressure in the tank may increase to a level that will cause the tank to vent gaseous fuel and reduce tank pressure. So steps should be taken to minimize this. You can find out more from your OEM or fuel supplier. Unlike CNG, there is no odor added to LNG system. And that's why, for safety, a methane detection system is installed on the vehicle to detect any possible fuel leaks.